2, 3, go. Malapit na pero malayo pa rin. Ganun talaga po.
And that's how we won our midterms competition. Hello, my name is Ralph Matthew Glafino Polencia Lagayan. I'm a 4th-year computer engineering student, and my name is somewhere displayed here in the leaderboards, and I'm here to teach you how to create your own, or this, obstacle avoidance / maze robot. Let's go. So, before we begin, here's a list of materials that we need to have first. If I put an X, that just means that I can't remember how much I used, so I just buy a whole pack or two, because I used a lot of them. Especially these super glue. Yes, those super glue, I used a lot of them. So I just buy a lot. So we start with coming up with geometric and precise measurements that we'll use for a mainframe, where we'll attach everything to this thing. This will be a relatively short video, so the actual measurements will be in the description. The actual assembly, well, description. This awesome ruler that I bought from Tico that I used to make all this, which is completely irrelevant, description. I'm not sponsored or anything, by the way, I just love that awesome ruler that Tico sells. I think everyone should have it. Anyways, if you follow my footsteps, you should end up with something similar to this, where two motors could fit perfectly with their wheels attached. After that, we need to test these motors with a motor driver. Then we can finally test those sensors.
Gingineering. Stop!
With all of those established, we just combine all of them, then tada! A fully working obstacle avoidance / maze robot. God damn. And after that, just call it a day. With all that said, now to actually understand how to create it, let's start with the motors and how to create your own motor driver. So the first thing that we need to understand are these motors. So these motors have two terminal blocks, one positive and one negative. So if you connect these terminal blocks to a power supply, at least in this orientation, if you connect a positive to a positive and a negative to a negative, it's going to spin counterclockwise. While if you interchange them, if you connect the negative terminal to a positive and the positive terminal to a negative, in this orientation again, it's going to spin clockwise. The orientation is very important, because if I'm at the other side of the screen right now, it's going to turn counterclockwise and clockwise. It's going to rotate at a different direction, so keep that in mind. So if I run this simulation, as you can see, the other one is spinning at 170 RPM, while the other one is spinning at the exact opposite, at negative 170 RPM. Why? Because I interchanged the connections of the negative to positive and positive to negative. And the next thing that we need to understand is our motor driver. And the motor driver that we're going to use is an L293D. So what is a motor driver? A motor driver is basically an IC that addresses one very serious major issue, which is current. Because those motors that I showed you earlier, or basically all motors, all DC motors, they actually draw too much current and too much power, that to the point, if you connect them directly to an Arduino's digital pins and set those digital pins at highs and lows, it's actually going to draw too much power and current to the point that it's either not gonna spin or it's gonna destroy your Arduino. So with that, it's basically a solution. It's a buffer that provides enough current. What's a buffer? A buffer is basically a yes gate in logic gates. So I just mentioned that because here we have input 1 and output 1, output 2 and input 2, input 3, output 3, input 4, output 4. So what do you mean by a buffer, right? So a buffer is basically if you input positive, it outputs positive. If you input negative, it outputs negative. That's just it. It's just why it's called a buffer. It just buffs the signal. Just buffs it. So it's basically the truth table is just like input 1, output 1. Input 0, output 0. So with that, let's go with the pinout. For the pinout, we have 2 VCCs, 2 enables, 8 input and outputs, and 4 grounds. Let's talk about the 2 VCCs first. So earlier I mentioned that an L293D is basically just a buffer. So to turn on that buffer, we need to apply positive voltage to pin 16, which is VCC1. VCC2 on the other hand is basically just a different power supply to power your motors. So if you don't power this, your motors won't spin, because the voltage you apply here is directly proportional to the speed and RPM of your motors. So the more voltage you apply here, the faster your motors spin, the higher their RPM goes. Next is the enable 1, 2, and enable 3, 4. So basically, if you apply positive voltage to pin 1 or pin 9, you're basically just telling the L293D that, hey, I'm using these pair, I'm using these pair, or I'm using these pair and these pair, because by itself, by the name, enable 1, 2, so I'm enabling input 1 and output 1, and input 1 and output 2. On the other hand, if I enable pin 9, I'm enabling output 3, input 3, input 4, and output 4. Sorry, I'm having a difficult time because, in, out, out, in. That's just the layout. Next are the input and outputs. So earlier, I already mentioned that an L293D is basically just a buffer. So if I input positive, it's going to output positive. If I input negative, it's going to input negative. That's just it. For the ground, there are 4 grounds because these grounds are basically connected internally. This is just a big chunk of metal. Why? Because it's basically a heat sink. Because if you add so much voltage to VCC2, it's basically going to dissipate so much heat because of that much power that's powering your wheel. So to address that, this is basically a big heat sink. These 4 grounds. That's just it. So we combine everything we just learned about the motor and the motor driver and add a bit of code just to control how it goes forward and backward. So as you can see, an L293D can accommodate 4 motors but can only go in one direction, or 2 motors that can go in both directions. We're going to need 2 motors that can go in both directions if we're going to make the Obstacle Avoidance Robot. So here, we just start with one, and let me explain to you what is going on here. So as you can see, I have a switch. See? If it's red, it goes clockwise, and if it goes green, it goes counterclockwise, right? In this orientation, okay? So now, let's lock in. So what is happening here? So basically, we have 3 pins. 2 of them are outputs, and 1 of them is an input. It's from a switch. So basically, we have a function here. It is void forward. So forward, it sets pin 10 and pin 11 high and low. So it makes pin 10 high and pin 11 low. While backward, it makes pin 10 low and pin 11 high. Sounds familiar? It just interswitched the polarities of the terminals of the motor itself. So basically, it says here, if the control state or the control state pin, this pin, if it's high, then it goes forward. If it's not high, if it's negative, it goes backward. That's what's happening. See? Now let's add the second motor so that you can see how you're going to code it. So we add a second motor. There we go. We connect it. Connect. Let me fix. Right. Now we need the inputs. Let's say 12 and 13. Let's make this yellow. There we go. Now we code it. So we just add 13 and 12. course, because we're going to use them. 12, 13. Now for the forward. This is where the coding actually matters, because if you interchange them, you should know, right? You should know. So let's just copy them. Okay. Pin 12 and 13. To 12 and 13. So it should basically work now. I hope so. I don't know. Start simulation. Ah. Ah! I needed to name it pin 12 and 13, I'm sorry. Now we start again. What now? Pin 113. Start again. What the? Okay, we're missing a comma. There we go. So as you can see, this is where the coding actually matters, because as you can see, it should run both directions, right? So we're going to fix that. Now it's in low. No, it's in high. So basically, we need to interchange them. This needs to be low. Low and high. Low and high. No, this is high and low. Because we're interchanging the polarities of the terminals of the motor, so that when it spins or when the Arduino sends out its signals, we get a reasonable output that we like. So now let's start the animation. See? Now they're rotating at the same direction. Now, we turn it. Damn! Works. And now, that's just it. That's how you're going to code it. That's how I'm going to discuss the coding later. And that's how basically the whole connection of the L29 3D matters. And that's how this whole operation even operates. Now let's talk about how to power, wire, and connect all these components together to create the project itself. But before we do that, just keep in mind that we're making our chargeable project, so please use rechargeable batteries as well. Anyways, without further ado, let's do this. So first off, we start with the battery. I used an 181650, which is rechargeable, and fed it into a BMS, or a battery management system module, which produces 3.7 volts. And is being fed into a switch that's, when turned on, is being fed to an L293's VCC2 pin, and also to a DC-DC step-up converter that converts the 3.7 volts into 5 volts, which our Arduino Nano needs, because the Arduino Nano will now use that to power all the components, all the sensors, and all the enabled pins that we need in the L29 3D. So, lastly, we add a 470 microfarad capacitor in parallel to everything the Arduino Nano powers to stabilize and make the power distribution reliable. Next, we just connect the digital pins, the motor pins, and the LEDs. Don't forget to put the 220 ohm resistors before the LEDs, and the orientation of the sensors are as follows: right, left, and front. And with that, we can now code it. Finally. Inabutan na ako ng umaga. Alright, let's start coding listing, but first, check the description below because the code is actually already there. But you're not going to be so lucky. I mean, if you are lucky, we're going to have the same connections, same pinouts, and same wiring, so the code will work. But if you're not, you're going to have to understand how to create the 4 core functions that drive this thing, which is go forward, stop, turn left, and turn right. So without further ado, I already have this. The similar wirings. I also used pins 2, 3, 4, and 5 for the L293D, but I don't think that I have the same code, so we're just going to recreate it here. And I'm having 2 LEDs, one for red, one for green. The green will indicate that it's going forward or nothing is being detected, and red just means that we have to turn. So the red will light up if we're turning, and the green won't light up if we're not turning. The green will only light up if we're going forward. So as you can see in the code, I already coded them or set them all to outputs. And here's the forward, here's the backward, the earlier functions. That let's just make this stop. We're going to make another void. Turn right. And turn left. There we go. So now, So now we have digital pin 2, 3, 2, 3, 4, 5. So for the forward, we just have to see if it actually goes forward first. Oh no. This one, I don't have a pin 10. Let's just make it 2, 3, 2, 3, 4, and 5. You know what? All of these are wrong, so let's just do this. Okay. There shouldn't be any errors now, but nothing's gonna happen. There we go. So now we put in the void loop. We're going to test the forward function. So in the forward, we set high-low for pins 2, 3, and low-high for pins 4, 5. Let's see if it's going to go... Ah, see? They're moving in the opposite direction, so let's make them right. I'm going to make this high-low. High-low. There we go. Now they're both moving forward. So for the stop, obviously, what we're going to do is... Oh, wait. For the stop, obviously, what we're going to do is just set them all to low. Now we test it. Stop function. There we go, it just stopped. Anyway, for the turn right, we need the motor on the right to go forward and the motor on the left to turn backward. Wait, it's actually interchanged. So we need the motor on the left to go forward and the motor on the right to go backward, so that it turns right. In your orientation, it's going left, but on mine it's right. So come on, turn right. Is it already doing it? No, this one's turning left. So let's make it right. High, low. Low, high. There we go. Now we just do that on turn left. I think turn left is already good. Yep. Anyway, now we use the LEDs so that we just know that they're going. Let's say, what's green? Green is 12, so digital pin 12. Hi. Let's go to forward then. There we go. Now for the left, I mean for the turning ones. We just add pin 13. Pin 13. Oh, it's still going forward, my bad. Ah, wrong spelling. There we go. Red. Turn right. Red. And stop. There we go. So, if you look at the code that I'm going to provide, there will be delays. Those delays will be just, because if it's turning, you need to know how long does it turn. So, for example, see, it just turns for 0.2 seconds. See, it refreshes every second, so that you know that it's toot, 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 toot. I'm sorry. That's just how it works. So my initial design didn't really work out because I used infrared sensors. I recommend you to use the ultrasonic ones that we already used, but if you're really stuck with these infrared sensors, you can make it work better than what I had here if you put a cover in its tip to properly direct and control their sensitivity. Next up is to make sure to use high capacity batteries like these ones that I'm showing here because this project is somewhat really power hungry. Also, if you want to make it faster, just add a step up here. I already did that, but I didn't put it in the final project because it's way too fast. Anyways, if you have the time, which I wish I had because we were only given a week to do this, instead of using a lazy cable to power the Arduino, you can directly use its 5V pin just like what I did here when I was testing it. Lastly, let's address the elephant in the room, which is how about doing this with a kit? Well, in my experience and according to my professor, kits won't really work if you don't know how to track their front. So basically, it's either you need to buy a really expensive kit or code it yourself. None of the kits didn't really went through that simple course in their first try, but hey, the important thing is I won on my first try and I got a perfect midterm score. Well, that's all for now. Everything will be probably in the description, And if you need help, just comment. I will try my best to respond. Oh, we can help each other, bro. Magtutulungan tayo dito. Anyway, I had a hard time figuring all these on my own, so I hope this video helps. Goodbye, paalam, salamat.